Hello everyone, welcome to the OneClass channel. My name is Marlon. I'm a second year student at the University of Waterloo studying chemical physics and math. Today I'm going to be going through some high school level and college level algebra problems. Be sure to check out the links in the description if you're in need of any extra homework help or like some one-on-one tutoring. Okay, so for our first question, we'd like to find the x-intercepts of a quadratic function. So we need to understand what the x-intercepts are first. And for a quadratic equation that has the form y is equal to ax squared plus bx plus c, the x-intercepts occur when the function crosses the x-axis. And so if you just quickly look at a function, so let's say 4x squared plus 4x minus 2 squared plus 3. Yeah. Let's do minus 3. Okay, so the x-intercepts occur right here. So the two places where the function actually crosses the x-axis, and you'll notice that the x-axis is of course placed at y is equal to 0. So the x-intercepts occur when when y is equal to 0. And so we'd have 0 is equal to ax squared plus bx plus c. And so depending on how many times the graph is crossing the x-axis or touching the x-axis, because you could also just touch it right here at the bottom, could be the only place that touches the x-axis. And so you can either have it in the form of x plus d squared, or you can have 0 is equal to x plus a, x plus e. And so no matter what it is, you should have a total multiplicity of 2, so that you can have x to the power of 2 in your total function. And so let's look at an example really quickly. And so let's say instead of having the function I initially pulled up for you guys, let's instead be dealing with the function x squared plus 2x plus 1 really quickly. So for this one, I can see that indeed it is touching the x-axis at one point. So my final answer is going to be of this form. And I'm going to have to find out what that d value is. And so I can go about finding what that d value is in multiple ways. I could use product sum, but the best formula to use is going to be the quadratic formula. And that just states x is equal to negative b plus or minus the root of b squared minus 4ac over 2a. And my a, b, c's are coming from a, b, and c here. And so, in my example, where y is equal to x squared plus 2x plus 1, I have a is equal to 1, b is equal to 2, c is equal to 1. And so if I just put all of those in really quickly, I'd get negative 2 plus or minus root 4 minus 4, 1 by 1 over 2 by 1. 4 minus 4 is 0. The root of 0 is 0. And so I'd be left with negative 2 over 2. And so my only answer would be x is equal to negative 1. And so if x is equal to negative 1, this would mean x plus 1 is equal to 0. I just moved the negative 1 right on over, is equal to 0. But remember, I need to have a multiplicity of 2 because this plus and minus is what gives me that multiplicity of 2. And so In cases where my function just touches the x-axis here, like in this case, and you can see that I have gotten the right point, x is equal to -1, my function will become y is equal to x plus 1 squared. And if you actually expand this out, you'll get exactly what you had initially. And so this is going to be your answer. If you had a more complex function, that would give you, like let's say we wanted zeros at x is equal to 3 and x is equal to -3. This would become x squared minus 9 is equal to my function. Let's go ahead and plot that. You see my 2, -3, 3. And so that's just how you go about that. You can use multiple ways to find your x. As I said, you can use the quadratic formula. Other methods are typically derived from the quadratic formula, such as product sum, where you want your product to be AC and your sum to be B. And so I'd like my product to be AC, 1, and my sum to be 2. And so with that, I get 1 and 1. And these two 1s, 1 plus 1 is 2, 1 times 1 is 1. These two 1s are what I'm going to put into the brackets. And so it's going to become x plus 1 as my first one, and x plus 1 as my second one is equal to y, which is just that x plus 1 squared is equal to y. And that's going to be it.